Hello, in our previous class, we talked about using first degree equation to solve application problems, and I went further to explain how to, and I further explained how to solve application problem using first degree equation, and I gave you some steps that were actually followed to solve application problems using first degree equation successfully. So now I'll be talking on using inequality in one variable to solve application problems. And as we did for first degree equation, we're going to also do for inequality in one variable. There are also steps we need to follow to get a positive result at the end of our solving. So these are the steps. Step 1, we read the problem. Step 2, we identify what you're looking for. Step 3, you name what you're looking for and choose a variable to represent that quantity. Step 4, you translate into an inequality. Step 5, then we solve the inequality. Step 6, we check the answers. And step 7, we answer the question with a complete sentence. So I highlighted down some examples using to solve application problems in inequalities in one variable. When using inequalities in one variable, so I highlighted down some examples, and I'm going to use the steps to actually produce a reasonable result at the end. So this is the first example 1. Ima got a new job and we have to move. Her monthly income will be $5,265 to qualify to rent an apartment. Ima's monthly income must be at least 3 times as much as the rent. What is the highest rent Ima will qualify for? So it's using the steps now to solve. The first thing on our list is what? Is read the problem. So we're going to reread that problem again. They said Ima got a new job and will have to move. Her monthly income will be $5,265 to qualify to rent an apartment. Ima monthly income must be at least 3 times as the rent. What is the highest rent Ima will qualify for? Now we have now read the question. Now what next? Step 2. What are we looking for? So we're looking for the highest rent Ima will qualify for. If you read the question very well, it's at the ending. They say what is the highest rent? What is the highest rent Ima will qualify for? And they say what are we looking for? We're looking for the highest rent Ima will qualify for. Then step 3, you say what are we looking for and what variable should we use? We know what we're looking for. We're looking for what? The rent. We don't know what the rent is. We don't know how much the rent is. We're trying to get a fixed amount for the rent. So we'll now say let x be equal to the rent. X is an unknown variable. We don't know the amount here, so we instead use x in place of what? The rent. So when I talk about rent, we'll put x there to represent what? The rent. Step 4. They translate into an inequality. But before we do that, we first write a sentence that gives the information to find it. Before translating into an inequality, you write a sentence that give an information to find it. But if you feel you won't get confused, so you can just translate it to an inequality direct without writing any equation, any sentence to find what you're looking for. So the sentence is: Iman's monthly income must be at least 3 times the rent. And here, this is greater than equals to. This is less than equals to, and this is greater than equals to. It's the same thing as this sign, equals to, but in inequality, we don't write equals to like this. We use this 2 in place of this 2. So we don't write it like this. We use this 2 instead of this 2 in place of inequalities. In place of equation, we can't use this. We use this. So step 5, we'll solve the inequalities. Now I've already written the inequalities down, which is $5,625 is greater than equals to 3x. You know what 3x came? Do you know where that x came from? That 3 came from. But we already know the x is the rent. And I said in the equation, I said Iman's monthly income must be at least 3 times as much as the rent. So you multiply 3 by what? By the x. So that what brought us back here. Now, they've gotten 3 times the rent. That's 3 times what? X. So I translated it already. 3 times what? 3 times x. That's 3 times the rent. Now, what we do next is we divide both sides by 3 to clear what? To clear x. To bring x, to allow x to stand on its own. So we can get a final answer here. We're clearing x now. You divide both sides by 3. When you divide here and here by 3, you get 1. 1 times x is x. When you divide $5,625 by 3, you get $1,755. So now, you now brought it down here to write it clearly. So $1,755 is greater than equals to what? X. It's less than equals to x, not greater than. This is a less than sign. Less than equals to x. No, this is less than. Sorry, this is greater than equals to x. Sorry for that mistake. So now, if you recall, well, when I was telling you the properties of inequalities, I said in a point that a greater than x has the same meaning as x less than a. So we now interchange and bring this one here by changing the sign, making it x is less than $1,755. So now, step 6, we check the answer in the problem to make sure it makes sense. So now, a maximum rent of $1,755 seems reasonable for an income of $5,625. So now, step 7, answer the question with a complete sentence. So the maximum rent that a man needs to pay is $1,755. Now go to example 2. Eloyd has a landscape maintenance business. His monthly expenses are $1,100. If he charges 60 per job, how many jobs must he do to earn a profit of at least $4,000 a month? So going back to our steps, so our step 1 will say read the problem again. So we'll go back to the question. Elliot has a landscape maintenance business. His monthly expenses are $1,100. If he charges 60 per job, how many jobs must he do to earn a profit of at least 4,000 a what? A month. Now I've read the question. Step 2. What are we looking for? Number of jobs Elliot needs. That's what we're looking for. Now, step 3. What are we looking for? Name what we're looking for and put a variable to it. So now we're looking for number of jobs Elliot needs to do. So let X be what? The number of what? Number of jobs. We have named the number of jobs what he's looking for. And let X be what? The number of jobs. So now step 4, we translate into what? An inequality. So writing a sentence first, 60 times the number of job minus 1,100 is at least 4,000. What it means is this. You say 60 per job. How many jobs must he do to earn a profit of at least 4,000? So I'm minusing 60 from 1,100 to get at least what? 4,000. That's what we did here. So now 60 jobs, that is 60 times what? X. That's what to give you what? 60 jobs you need to do, because the job is what? X. Because I don't know what the amount of job is, I think we get the amount of jobs. So it's greater than equals, it's less than equals to what? Now got the first one here. Sorry for jumping. It says TX minus 1,100 greater than equals to what? 4,000. So now we collect like terms. In our first video I talked about you are allocating terms. Right? You just allocated this 1,100 to this side, and the sign negative sign became what? Positive. So now we had 60x greater than equals to, after solving this, we get 5,100. 4,000 plus 1,100 give us 5,100. So to get your x, we divide both sides by 60 to clear what? To clear x. When you divide here by 60, you get 1. 1 times x is x. When you divide 5,100 by 60, you get 85 jobs. For x is equal to what? 85 jobs. So our step 6, check your answer. If Elliot did 90 jobs, his profit would be this: 60 times 90 minus 1,100 equals to 4,300. So this is more than what? 4,000. I'm looking for what to give him 4,000. But if Elliot must work at least 85 jobs, he will get exactly what? 4,000 a month. So Elliot needs just for 85 jobs to get what? 4,000 per month. Now example 3. Pet works at a computer store. His weekly pay will be either a fixed amount of $925 or $500 plus 12% of his total sale. How much should his total sale be for his variable pay option to exceed the fixed amount of $925? Solution: we already know the steps. I've already read the questions, so let's go down to step 2. The total sale needed for his variable pay option to exceed the fixed amount of $925. That's what they're looking for. So now let X be the total sale. So we are using X for total sale. Now we convert 12% by dividing it by 100. So now when we divide by 100, we get 0.12. So therefore, we are translating into an inequality now. Get 500 plus 0.12x, because this is number of this is the percentage of his sales, of total sales. 0.12x is greater than what? 925. Now collect like terms. 500 500 comes to the other side, and we have 925 minus 500. So we're getting 0.12x is greater than 425. We divide both sides by 0.12 to clear what x. Divided by 0.12, you get what? You get 1. 1 times x is what? X. When you divide 425 by 0.12, what you get is $3,541.66 what? Kobo or cents. So now we need to round up the sales up to 4,000. So when rounding up the sales up to 4,000, we get 5,000 plus 0.12 times 4,000 equals to what? Equals to what? They give us what? $980. So, and 980 is more than what? 9,200 and so $925. So the total sales must be more than $3,541.67. That is total sale. To exceed this amount, the total sale must be more than this. To exceed this amount up here, this amount here, okay, so his total sale must be more than this. Thank you for watching. Thank you.